Hello everyone, in this video I am going to discuss about error detection using parity checks. This topic comes under in error detection and correction. What is error detection using parity checks? It means ensuring data integrity in digital communication. The main objectives of this error detection and correction is first recap the data transmission basics. In define phase, what is the problem of noise? In ideate phase, at the parity concept. Prototype is it has two types of parity checking, even parity and odd parity. In test phase, hands-on detection. The main objectives of the learning is understand the need of error detection, implement even and odd parity bits, analyze the limitations of parity checks. These are the main objectives we are going to discuss. The data transmission challenges are how data travels. In digital communication, the data travels as bits, that is zeros and ones, across channel like Wi-Fi channel, copper channels or fiber optic channels. The reality is no channel is perfect. That is noise, electrical or interference or physical detects can flip a bit. Here send the data that is 1, the receiver receive the data is 0. This is an bit error. How do we know it happens? In design thinking, first you empathize and define phases. First you empathize, meet Priya. She is a network engineer. She manages banking transactions. A single flipped bit could change 10,000 to 90,000. She needs a simple, low-cost way to know if data arrived safely without asking the sender to repeat everything. In define phase, the core problem, the main challenge is how can we detect if data has been corrupted during transmission using minimal computational overhead. The constraints are must be fast, must use minimal extra bandwidth. In ideate phase, the parity solution is we add an extra bit to the data to make the count of ones either even or odd. The parity bit is the extra bit doesn't carry data. It is a guard that checks the total count. Even parity means total ones equal to even numbers. Odd parity means total ones equal to odd numbers. In prototype, even parity in action, here data is 1011. Even parity needed add 1 to make total 4. In original data is 1011. Here 3 ones, add 1 for even. In transmitted data 1011 parity bit. Transmitted code is 10111. Valid if 4 ones, 3 ones trigger resend request. How it works, the algorithm is sender counts the number of ones in the original data block. Count the ones 10110. Here the total is 3. Step 2, append. Sender adds a parity bit 0 or 1 to force the total to the agreed rule. Here binary data is 10100, that is parity bit we can append. Step 3, verify. Receiver counts the ones. If the rule is broken, an error is flagged. Data bit is 1011, the parity is 0. Here error detected, the rule is even parity, sum is 3. In quick check, we are using even parity, the data is 10110. What is the parity bit? 110 or null? The answer is 1 0. In discussion, the critical thinking limitations are if two bits flipped, example 0 1 becomes 1 0, does the total number of ones change? Can parity detect these errors? No, the total count of ones remains the same. The parity checks can only detect an odd number of bit errors 135. They fail to detect an even number of errors. In summary and key takeaways are the purpose is parity is a simple method to detect single bit error during transmission. Types are can be even parity, the total ones is even, or odd parity, total ones is odd. The limitation is cannot detect double bit errors where two bits flipped simultaneously. Thank you for watching this video.